far, we have experimented with outputs that send out signals from Galileo. From now on, we will do lab with inputs that receive entry of data. Keyboard is just one of them. Go to the IDE's File menu and select Example. 8-point strings, click Character Analysis, and you will see a new sketch screen. Click the upload icon and check the message Transfer Complete. There is a serial monitor icon on the top right of your screen. Click on it. Type in K and 7. Next, type in the special character at and look through the new screen. You can see the ASCII value of each key through the function serial point read from the sketch. ASCII code table is a table for expressing letters in numbers. It is used for computer or telecommunications by defining each letter that corresponds to the decimal number 0-1 to 7. To check the ASCII code table by sketch, click the menu File, Example, and ASCII table in order listed. Digital is a technology used to express all the information in a series of digits 0 and 1. 0 is called low and 1 is called high. Let's have a digital input lab with push button or switch. Plug a push button on the breadboard. In the case of push button, you should be aware that two pins are connected together as a pair. One of the pins that are not connected to each other, connect one to Galileo's 5V using a jumper wire. The other pin needs to connect to two ways at the same time. First, connect to Galileo's digital pin number 2 using another jumper wire. Next, connect to Galileo's GND through 1K ohm resistor. The 1K ohm resistor used in this lab is called a pull-down resistor. It may seem like it becomes high when you press the push button and low when you take it off without pull-down resistor. However, actually, without the pull-down resistor, it becomes very unstable. We call this state as floating and you must avoid it. Click the IDE File menu and select Example, then click 2-point digital and button one at a time. In the new sketch screen, press Upload icon. Continue to press and release the push button and you will observe the reaction of the LED on the Galileo. The digital read function in the sketch is to receive input of the push button. What do you think is the principle of controlling the speaker's volume? In fact, the speaker uses the potentiometer. Galileo interprets the inputs of the potentiometer as analog signals. Put a potentiometer on the breadboard. Then use a jumper wire to connect one side to the potentiometer's middle pin and the other to the Galileo's A0 pin. The remaining two pins of potentiometer should be connected to Galileo's 5V pin and GND pin using other jumper wires. In the Galileo board, there is an electronic device called ADC which converts the analog value of 0 to 5V to digital value of 0 to 1023. Go to the File menu, select Example and click the analog input which is under the 3-point analog file. Click Upload button in the new sketch screen. If you slowly turn the handle of the potentiometer, you will see the changing speed of blinking LED on the Galileo. The analog read function of the sketch receives inputs from the potentiometer. An electronic sensor tells something about its environment by creating an electrical signal. This time we will experiment with reaction of a light sensor to the surrounding environment, not controlled by human. Galileo reacts to the degree of its surrounding brightness. Use the same jumper wires connected to the Galileo as they are. Now replace the potentiometer with a light sensor on the breadboard. Connect the jumper wires to VCC and GND of the light sensor with the Galileo's 5-volt pin and GND pin respectively. The jumper wire of Galileo's A0 pin should be connected to the out pin of the light sensor. There is no source code for this experiment in the IDE's example, so you need to download the lightsensor.ino file from the homepage. Select IDE's File, Menu and Open, and then search for the lightsensor.ino file and nuke. Click Upload icon in the new sketch screen. The next step is to click Serial Monitor icon and see how the light sensor reacts to a certain degree of brightness. You can do this experiment using curtains or blinds, or you can use your hands to cover up and let go of the light sensor repeatedly. 0-point println function writes the input values of the brightness received by the light sensor.